Hopefully you're okay, that's great. So welcome to this session. We are going to start with our session. So welcome everyone. I've seen that you come from different parts of the world. I don't know if it is good morning, good evening, good night, or whether it is in the middle of the night, whatever. So welcome, you have chosen to be among us today. And hopefully I'm going to add value to you. At least you're going to learn one thing and maybe one skill, one thing which can help save your life. Why not? Not only in IoT, because it's going to be general. When we talk about electricity, electrical engineering, it's always good to learn new things. So is there like a common denominator to IoT, Internet of Things and electrical engineering? Maybe yes, maybe not. I'm going to see. So while I was requested to have such a presentation to you, I was wondering what can I cover to add value to you? Basically, I'm here to add value. And so as an electrical engineer, I wanted to say, okay, this is a black box, which is IoT. And how do we interface with that box? Maybe for those who are non-engineering and so on, and they need to interface with an electrical engineering, what do they need to know? So I've prepared a few slides for you. Hopefully these are going to be helpful. And if not, we are going to have like a question and answer session at the last, maybe at the end of this presentation. So feel free to ask any question. And if it is easy, I'm going to answer it. If I know, if I don't know, maybe we can keep in touch and we are going to look for the answer and maybe we can discuss on that later. I don't have all the answers, I think, and I've done my PhD. So when you do your PhD, it's not that you know more than others. Actually, you see further than others. And when you see further, you know that you don't know so much more. Okay, just a way to see. Like maybe you have jumped onto a mountain and you see further away and you see the big horizon. You see how much else you don't know basically. It's not like you know more ultimately. So let's remain humble and let's see what I have for you for today. So if you're ready, let's hit it, guys. Okay, about myself, I think Zuleika did like quite an impressive, I was impressed by the presentation she gave me as introduction. So basically, I am from the Central Electricity Board, the only power utility in Mauritius. Okay, I've been working there for the past 15, 16 years now, and I hold a few certifications. Basically, why do you see a lot of these acronyms and so on after my name? Postnominals, we call that, because I love to learn. I have taken the promise. I promised myself that I'm going to die a student, always learning. Today itself, I think I enroll on 5 to 6 courses online. So maybe I won't be able to complete all of them. I have a few unfinished books as well. So it's up to me to just keep abreast of what's happening, to learn new things so that you can keep your mind like young. Okay. And so basically I'm a coach and in different sectors, but I specialize in leadership. Okay. How to go from one level to the next in terms of leading. Leadership is not only for maybe for those like we call managers and so on. You can choose to be a leader at home, in your workplace, on the football pitch, wherever. So this is basically my field of expertise, that is to make someone go from one level to the next. That is what you call to enhance his living, his mindset, and so on. So this is about me. Let's forget about that. This is how you can reach me. You have my Gmail address, my mobile phone, and my website address where you have much more information about that. Okay, so about IoT, what is it all? I think I heard about IoT 10 maybe years back, and for the IT, we did a presentation on Internet of Things. I didn't know anything about that at that point in time. And I was telling me, there was a video which was shown. I was telling me, do you think this can be realized in time, maybe in 5 years, 10 years? But nowadays, okay, as you can see, it's like maybe they are going to talk about Internet 2, the new Internet, the second generation of Internet, because the one that we have won't be able to hold this amount of information, what we have new terms like big data and so on coming in to manage, to consume, to be able to digest all these amount of information, because we're having data, we have a data overload syndrome nowadays, too much of data. Okay, so IoT is ultimately going or is already getting into our home, our television, our refrigerator, our cars, our wearables, okay, on ourselves as well. Maybe we are a piece of IoT ourselves. We don't, maybe you have a chip inside us. We don't know with a vaccine that they are like just putting into us. We don't know exactly what's happening around us, but IoT is here and it is becoming much, much more important. It is going to maybe rule the world in a few years. Okay, nowadays we are talking about its role in industry. We have reached industry 4.0. Why not 5.0 with IoT accelerating this change here? As you can see in the picture, from work to home, in your toilet, I don't know, everywhere you are going to talk about IoT in a few years. So how can we enable such technology? We call that this type of technology disruptive technology, because it's going to disrupt, it's going to change the way we are going to approach our life. Now, when we talk about IoT, good, you have a network. I think you're going to have a session on networking, communication network. Very good. You're going to have a session on you're going to have a session most likely on the antenna or the communication system and the sensors as well. But now we need to connect that. It's not like a box. We just put it there like a flower vase and then, yes, it's IoT. You're going to stay like that. No, no, no. We need to interface it with what we have at home. Maybe your television, refrigerator, or is it that, okay, tomorrow morning we go to, in Mauritius, we have Course, where it's like a shop where you get all the furniture, all the appliances and so on. We just go there and we buy all IoT equipment. No, it will need to take its time to change. Maybe with time, it's going to be included in the new equipment that you are going to buy. But what do we do with what we have currently at home? We can't just throw that away. We'll need to have a form of retrofit. Okay, what is retrofit? You add the intelligence, you add the module to the existing equipment that you have. So you will need to interface. While you were working with IoT, a small device, I have been supervising lots. I don't have lots of experience in terms of maybe coding, maybe Arduino or Raspberry Pi, whatever. I leave it to your generation, the Z generation. I prefer to have to see it as a black box and then, okay, what can you do to that? This is our input, this is our output. I can interface it. This is what I'm good at, but I don't know too much about IoT, the programming, whatever, the different layers that you have in it. Maybe this is, I will going to leave it to you because this is your baby ultimately. But then when you're doing IoT, so I was telling you, I have supervised, not supervised, but moderated a few final year projects, engineering final year projects, where you have been using what we call IoT devices, IoT projects, and so very good projects. Okay. However, okay, you can see that still on a breadboard. Okay, not well packaging, but it is doing its way. It has been, you can prove that it is achieving the aims that it was meant for. That's good, isn't it? But now when you need to implement that in the actual world, you can't have like a wires hanging maybe next to your door, to your refrigerator and so on. So we need to have it like more professional. This is what I'm going to cover. I'm going to cover a bit of battery. Okay, battery sizing shortly, because I'm going to keep it 1 hour, 15 minutes so that we can have ample time for questions. Hopefully, it's going to be in this slot. So let's get started. When we talk about electricity, move to the next slide. Okay, when we talk about electricity, before coming to electricity, we talk about electrical engineering. That's the big picture, the mother of engineering, of electrical engineering, under which you have electronics, you have maybe IoT, and then you have communication. But the first one, okay, the main one is electrical engineering, which has ultimately with time and correctly, okay, like split into different types of engineering as well. So electrical engineering is a big picture. But underneath for today, we are going to start our talk with electricity. Then we are going to find our way all through what I have chosen to share with you in terms of the link between electrical and IoT. Hopefully I will be able to give you a few ideas. So let's get started with electricity. You know this guy, okay, he's playing with electricity. So when we move from our low voltage, maybe we are working with 9 volts, 12 volts, and now we are going to retrofit, as I told you. Maybe you have your own television, your own refrigerator, whatever equipment, instrument, apparatus that you have at home, and you're going to retrofit. You mean to retrofit that, you need to add a form of intelligence to that. The things get serious, because there we are interacting with higher voltage. Higher voltage means safety. We need to take safety into consideration, but you will see that voltage is not the main issue. It's going to be about ting, ting, ting. Let's wait for it. So what is the difference now? You have seen, you have heard about maybe people getting electric shock, or maybe you have had a bit of this tingling effect as well when you're working on your project, or an electrocution. So what is the difference now? This baby is looking for help from you. What is the difference between electric shock and electrocution? Is it the same? Not necessarily, isn't it? You can still answer on the chat box, okay? Let's keep that quite interactive. So electric shock is the application of a voltage between two parts of the body. Maybe you are holding two connectors, two cables in your body. Okay, I'm seeing a few of those. Sure, very good answers. Okay, a few answers in the chat box. That's very good from you. So electric shock, application of a voltage between two parts of your body. So you can have a tingling effect. You can have maybe it may prompt you to start dancing as well. We don't know what type of tingling effect, where it's going to tingle you ultimately. So else electrocution, now we are getting serious, guys. Electrocution is an electric shock. So it's what we have just defined. So it's this tingling effect, which is maybe to the higher threshold, higher level, which results ultimately in death. This is serious. Okay. So electric shock is okay. We can have a small burn. Okay means that, okay, it's not death as such. Death is like non-reversible, but it can be a form of burn, which is quite serious at times, maybe amputation as well, depending on the current that has gone through, on where it has gone through your body. So this is why we need, I'm not like trying to make you afraid, to scare you, but this is what it is. When we are dealing with electricity, we need to be cautious, we need to be aware that it is a serious, it's not a playground anymore. Okay, it is serious issue, and still like we are going into the deep engineering of things. Anyway, why do we have, let's say before starting even considering your IoT devices, your lab equipment, your lab maybe things that you are doing, your project that you are doing, or any items that you are trying to do, any activity. So you need to be cautious about the insulation. These cables, this is what you have inside. So copper wire, this is what is carrying current. This is carrying current, and over this conductor, we have what we call an insulation layer. So insulation is achieved by using insulating materials. Basically, we have PVC. The general that we have in our home is PVC. PVC is quite a very good insulator, but however, it is like soft. So you can't just maybe squeeze it in the doors, or maybe in some area is going to damage the outer layer, and ultimately your cable, okay, your conductor, inside conductor is going to be visible. It can protrude, and anyone touching that is going to have either an electric shock or electrocution. Which one would you like to have? Hopefully you're not choosing any one of these. So we want to like avoid such happening, okay, such mishap. Anyway, so an insulation fault, okay, irrespective of its cause, present hazards for human life. You can have a burn, you can have a quite serious electric shock, or even electrocution, as you already know by now. Present hazard for human life. Preservation of property. Why? Because even if it is maybe touching another spot or a neutral, the live is touching with a neutral, it can cause flash. And flash, maybe if you have wood around, paper around, maybe any flammable object or thing like that, it can cause a fire. And most fire in houses, I don't remember, basically, let me just say, should be around maybe 80% to 90% of all fires in houses are caused by poor electrical installation. So we are just putting it in the big picture. We are relating that to IoT, but since we are discussing on that, it is like a safety precaution that you need to, when you're going to connect your cables with what we have equipment working on 230 volts, like higher voltage as you are used to in your project or a small IoT device. So you need to be aware about the cables that you're using should be safe, should be properly having proper insulation and so on. So else it can cause harm to you, animals as well. It can cause harm to the building, to the infrastructure you are working in the lab, in home, in whatever, in your small lab at home as well. So availability of electrical power. If you have a fault, is going to damage your equipment. or it can damage your installation. What's going to happen? You won't have electricity. And when you don't have electricity, you won't be able to attend the upcoming seminar, webinar in IoT Festival, isn't it? So it's up to you to see to it that you are using the appropriate cables with proper insulation. This said, is it safe, since we have it in the picture, is it safe to have these cables in loops like this? You will say, yes, this is why we do extension code and so on, isn't it? No, it's not safe. I won't go into the details, but when you have it in loops like as this, it's in electrical engineering, it is as if you have an inductance. Okay, an inductance, when you have a current flowing through that, is going to increase the current flowing. Increased current is going to cause heat, okay, because you have different effects when current is going to pass through a cable. You can have the heating effect, it can be used maybe for light and so on, but heating effect, and then this is going to heat the cable and can damage the cable ultimately, as compared if it were straight. So every time you're using cables in reels, extension code and so on, see to it that extension tool should be used like for temporary use only, but don't like have it in reels like that. It's not safe at all. Okay, now, so you know these two guys, hopefully. Okay, so which one, okay, is more dangerous? Oops, I don't mean John Cena and The Rock. I mean current and voltage. So which one is more dangerous according to you? Is it current or is it voltage? Yeah, I see only one person. Okay, because you can't see me, isn't it? Okay, so what is most dangerous, current or voltage? Well, I'm seeing a few. So diverging views from the both. Yeah, both is dangerous. Let's have a look now. Okay, so we are going to share. It's a bit technical, but I'm going to show only the most important thing for you to do, because it doesn't come out from the blue. We have some theories to back up what we are going to tell you right now. So electric shock, basically a person or animal subjected to an electrical voltage. So we are holding voltage. Okay. For a potential difference is electrified. This person, let's forget about the animal for the time being. Okay, leave them behind. Let's focus about the human being. He's going to be electrified. According to the severity of the electric shock, this person may experience. Let's see what they can experience. Discomfort, maybe as we said, tingling effect, a muscular contraction, or a burn, or cardiac arrest, which leads to electrocution and which we call death ultimately. So it's serious, isn't it? Now, what is this? What is this figure shows us? We have on one side, the y-axis is the duration of the current in terms of how long the current is going to flow. Okay, and then on the x-axis, you have the value, the magnitude of this current. So if you have RCD, basically it depends on the earthing system that you have in your country, but for Mauritius and a lot of countries, we have the TT earthing system. And for that, we recommend the use of an RCD, residual current device. So if you have a look at the rating of this RCD, residual current device, it is 30 milliampere. 30 milliampere. So if we go into our graph and we look for 30 milliampere, this is shown in red, should be around here. Next to it, you have C1, the curve label C1. What does C1 show us? C1 is a threshold of 0% probability of ventricular fibrillation. Ventricular fibrillation is where the current is affecting your heart directly. So before C1, okay, this is where we have our red line, we have 0% probability. You have C2 where you have 5% probability of getting serious cardiac arrest, like and death as well, or you have C3, which is 50%. So we won't be going onto these limits. So we want to remain on the safe side. That's why our RCD will recommend that RCD should be rated at 30 milliampere. So what for us now, what is more important to know is that it's not the voltage which is killing the person, it is a current. A current beyond 30 milliampere can kill someone. 30 milliampere. Let's move forward now. Okay, so from 1 to 5 milliampere, this is what you have a discernible, you're going to feel something. Okay, but no, it's not danger. Up to 5 milliampere. Beyond that, from 20 to 50 milliampere, it's impossible to release a graph. Okay, maybe you have a cable which is damaged and you just maybe hold it by accident, you want to release it, but you will can't. The muscle contraction has happened and you can't release it. Okay, so impossible to release a grasp. Extreme pain and loss of consciousness, because from 20 to 50 you have this 30 milliampere limit, which is in between this range. Beyond that, from 50 milliampere to 75 milliampere, you get paralyzed with no pulse or respiration. No pulse means your heart has stopped beating and you're not able to breathe properly. And beyond that, greater than 100 milliampere, this is it's going to say bye-bye to you. Okay, ventricular fibrillation causing almost instantaneous death. You won't have time to bring him to the clinic, whatever. So 100 milliampere. We are speaking about milliampere. Milliampere. That's very small for a value of current. We are going to see in what are the values that we are used to. For instance, most computer USB ports supply 5 volts of electricity with a maximum current of 500 milliampere. Up to 500 milliampere. We just said that 30 milliampere is fatal. Beyond 30 milliampere, it can be fatal, isn't it? The USB can supply up to 500 milliampere. Okay. If you're using a laptop, the charger, the input side, which is connected to the power supply from your home, is using input for 230 volts, and it can supply 1.5 ampere, which is a current. Volt is the voltage. The output, which is connected now to your laptop, it is supplying 19.5 volts, and in terms of ampere, it is 3.33 ampere. Both are quite high. 1.5, it's not milliampere, it's ampere. Okay, so it's quite high. And both for input and output. But let's see whether this can maybe cause fatalities and so on. For the sake of this explanation or this calculation, this is what we are going to see next. What is a resistance? It depends on the resistance of your body. Okay, it has been shown through standards that they have and so on, that we take for our calculation a resistance of 1000 ohm for the body of a person. Generally, the average is 1000 volt. It depends on weight, height, and different things, but basically, let's assume 1000 ohm or 1 kilo ohm for the resistance of the body. When we were discussing on 230 volts and 1.5 ampere, so 1.5 ampere is the maximum current that it can handle. It can push 1.5 ampere. Okay, so it won't like automatically provide this 1.5 ampere. It's going to be the voltage, the 230 volt, which is going to provide the voltage level, okay, the potential difference, but ultimately is going to be the resistance that you have in between, which is going to dictate the current flowing. Where do we know that? We have learned about Ohm's law, isn't it? Okay, so Ohm's law, V is equal to IR, or we can say I is equal to V open R. So we are now, because we know that it's current, which can cause electrocution and so on. So let's say for the USB, we said it's 5 volts. Then we say, I think 500 milliampere, it's the maximum that it can give. It can provide in terms of maybe output. But what is going to define how much current is going to flow is going to be the resistance that it has across the ends. And for our body, 1000 ohm, you're going to have 5 milliampere, which is less than the 30 milliampere, which can be fatal. So if you are maybe you're touching the two ends of a USB terminals, okay, the wires that's inside, okay, positive and negative, you're going to have 5 milliampere. You're going to maybe discern it, but it's not going to be fatal for you. You can still release it afterward. If we take the charges, the input side, 230 volts, your body resistance of 1000 ohm, you're going to have a current of 230 milliampere. This one is above what you have, which is our limit of 30 milliampere. So this can be fatal for you. So this is what we call the high voltage side, 230 volt side. For the charger, again, on the low voltage side, which is connected to your laptop, it's 19.5 volt divided by 1000 ohm, and you're going to have 19.5 milliampere, which is slightly less than 30 milliampere. So basically, you can still work around it. It's not going to be fatal. You're going to have maybe a quite significant electric shock, but not an electrocution. It's not be leading to death ultimately. So you see, it's about, if you need to understand, okay, what is the voltage? Why is voltage so important? Ultimately, it's going to be current, which is going to decide whether you are going to have what type of shock are you going to have. But it depends on the voltage, because your body is quite 1 kilo ohm is quite high as a resistance. Okay, so basically this is what I wanted to share with you. So now we're working with both different types of voltages, AC and DC. Okay, so which one is more dangerous now? Question for you. AC or DC? I see lots of people, DC, DC, AC. I think it's a song, DC, DC, AC, 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 DC. Oh, I can see it. Yeah, very good. Okay, so it's like lots of DC. Okay, but I'm going to be maybe, I can see a few more. Yeah, AC, AC. Okay. So basically it's going to be, I see a question, let me just check. It's DC, okay. So I'm going to be maybe you will, or we can see a point for argument. We can always argue about that. It's AC, which is more dangerous. Okay, quickly for you, because we have lots of people who have said DC. When you are going to draw the curve for, oops, where is my, okay, DC is going to somewhere around here, direct current. Okay, let's say it's 230 volts. It's going to remain like this. But when we say it's 230 volts AC, okay, AC is going to be like this. But when we say 230 volts AC, it is RMS value. RMS, root mean square value. So what is meant by root mean square? This should be something around here. Okay, we take the square and then we square it. We take the square and then we root it. So ultimately what happened? This is a 230 volts. But the peak value, okay, it's just like an average that we are calculating. But if we take the peak value, it is slightly above 300 volts. That's what we call V peak. Okay, so ultimately this one, the peak, the highest voltage that you are getting is 230 volts, fixed. Okay, but for AC, it is a maximum voltage you are getting. Is when you say 230 volts average, what we call the root mean square value. But when we talk about AC, it's going to the peak value. V peak is 300 volts. It's much higher voltage, which is like stress upon you. So basically, it's going to be much more dangerous. But there are different maybe reasons as well. But for this one, it is quite, I think, the most plausible and which we can share with you. But different people have different thoughts as well. Anyway, I think hopefully depends on voltage and current. But let's take, I'm just a bit about the frequency as well. Yeah, if we go, maybe which one is more dangerous, 50 hertz AC or 50 hertz DC, 50 hertz AC or 60 hertz AC. So we can still discuss on that. But for this maybe situation that we are discussing with IoT and so on, we need to know that AC is more dangerous. So what I wanted to tell you that we need to be cautious about when we are working with AC. Slightly more, DC as well can cause it can have its consequences, but be very careful when we move from our IoT, small devices and so on. When we need to implement that, we are going towards our equipment, our apparatus and so on, which is connected to AC. Now we need to be slightly more, not slightly, but much more cautious about what we are doing. Okay, but how do we protect ourselves now? We said, yeah, it's dangerous. We need to be very careful. But how do we protect ourselves from electric shock? So let's have a look. We have an IC which defines these. So we have different types, but we won't cover all because this is pure engineering, electrical engineering. But for us, okay, let's have the essence of it, the root and the most important part. Protection under normal condition depends on the protection against direct contact. So we call what we call the basic protection. We have covered one already, which is about the insulation. We add a piece of insulation on that, isn't it? So we protect ourselves, we protect our body, our hands, or any part of our body, or even someone else. It may be a kid, another one who is not knowledgeable. They just want to touch. So we are not leaving the live part, let's call that the live part, exposed for human or animals, whatever. Okay, so we protect. This is called the basic protection. And then we have another one, which we call the indirect protection in case we have fault. This is where we have what we call protective devices. We just introduced one a few minutes back, which is an LCD. Remember, the residual current device. So we have an LCD. How does the LCD work, or why does it work? If we have a fault, okay, a fault current, and fault current was supposed to be flowing through you, but the LCD is going to detect this imbalance, current coming in, okay, is going to detect current coming in and current going out. This is your meter, and you have it, or this is your meter, and this is LCD. It is just monitoring current cutting in, current going out of your equipment. Okay, this is your equipment. If 10 ampere gets in, 10 ampere gets out, it's going to record nil because it's working on the difference. But let's say you are here, okay, and you are touching it, and it is giving you an electric shock. So current is supposed to be flowing through you and going towards the transformer, whatever. So this is going to create an imbalance. It may be 10 ampere here, it may be 9 ampere remaining, and 1 ampere going through Earth. So this balance is going to be seen by the RCD, and it won't wait for it to be 1 ampere, because 1 ampere is already, you are already buried. Okay, we are speaking about 30 milliampere. So when it is going to cross this threshold of disturbance, is going to trip. So you are protected. So 30 ampere, it is still, we can manage. You're not, maybe you're going to have like a small shock, but nothing serious as such, isn't it? So this is one of the protection which we call against indirect contact. And we are going to see a few more in what we have next. Okay, checking the chat quickly. Okay, we'll answer a few of these later on. Okay, this is what I wanted to tell you. Maybe you have worked on a project, your final year project, very good IoT security system. And you say, mother, I'm going to install it. This is my final year project. Don't worry about security system. Nowadays, I am the new guy in the town for security. So you just put it there. It's going to work, isn't it? But here, this one is not like interface with higher voltage, maybe your small circuitry and so on. But still, you cannot leave these installation like that. It's maybe for testing and so on, this is going to work, but not for maybe heavy duty when it's going to work on an everyday basis. This is not allowed. Okay, so you will need to go to the next level when it comes to this one. So how can we can protect? It's going to be much more beautiful as well. Okay, it's like a small casing. That's what you call protection against direct or indirect contact. Put it in a small casing, you can buy it, you can build it from plexiglass. Well, this one, what you have on the right-hand side, I think it's even waterproof. We're going to come to waterproof and so on later on, but isn't that wonderful? Okay, it's beautiful, well packed and so on. This is what I was telling you about, one of the ways by which we can protect our equipment, our circuitry from maybe direct contact for people not knowledgeable, even yourself. By accident, you can touch it. Okay, so just be careful on this side as well. So protection through insulation, we mentioned that. Protection by means of barriers or enclosures, or you can put it in a cupboard. This would be fine, isn't it? Okay, or you install the LCD to protect human and so on. Okay, next question for you now. I know I'm going to ask a few, maybe lots of questions as well. Okay, for you to clarify my doubts. So you have such a board, an Arduino, you like it, I know. Okay, so can it power a circuit or a breadboard that you have here with one LED? Will it possibly you supply and so on? Would you be able to light up this one LED? Anyone from the chat? Yes, definitely. Yeah, so that's very good. Very good answer. Okay, sure is going to. Now, if we say, okay, light up 10 LEDs, will the Arduino be able to do that? You would say, yes, most likely, yes. I think, yes, it's a continuation of a yes that we have. Isn't it? Very good. But now let's say we are going to, it's like Diwali is coming in, isn't it? Let's work out. Let's say, mother, I'm going to, don't need to for us to buy Diwali lights and so as for, okay, even Christmas lights. I'm going to do it my way. It's going to be like chasing and so on. It's my final year project. So let's light 20,000 LEDs. Will your Arduino be able to do that now? 20,000 LEDs. And let's go beyond that. Let's say 1 million. We can even go to the Guinness Book of Records. Okay, so basically from what we have from our board, we won't be able to, we have a limit by how much we can, what we call the load, how much load we can add to our board. So one LEDs, two LEDs should be manageable, isn't it? But then what is the limit? This is up to you to find, but I know that 1 million you won't be able to supply from this board. So what do we need to add now to be able to complete and to make it possible? The logic is here, the Arduino is here to give the logic. What do you need? It's about the programming. What do you need to light? When to light? What is a chasing? What is a sequence and so on? This it can be. This is about the logical part. But now about the powering. Let's have a look. This is maybe what's called another circuit. So how many LEDs? We don't know, but let's see. This is an introduction to what we call the relays. When we are going to add relays, exactly. Oh my God, you have an amazing audience. You already know exactly what's coming. Or maybe you have seen my slide earlier on, but fantastic, well done audience. So basically, let's say you have this circuit where you have the light off, you just switch it on. It's just like our circuit for our LED. But now, when we have maybe a bigger load, maybe a lamp, a 230-volt lamp or whatever, it may be a motor. You want to switch on maybe your refrigerator, your television. What else? What else do you want to supply? Maybe, I don't know, whatever you have around you, isn't it? So we can't maybe, because your Arduino is working maybe 5 volts, 12 volts, 9 volts, your circuit, whatever you have, different voltage in your circuit, but then you need to switch on a bigger circuit in terms of voltage and in terms of current as well. Okay, you can't have a circuit switching on another circuit containing maybe 10 ampere flowing. Is going to blow off your circuit, your board and so on. So basically, this is why we are going to introduce our saver, which is, as you rightly pointed out in the chat, is a relay. So what is a relay? It is just a device, okay, which is going to help. The Arduino is going to give the Arduino circuit is going to give the command open or close, and this relay is going to switch on or off another circuit. At times we have normally open or normally closed depending on the relays, and it can switch it on or it can switch it off depending on the command it is getting. So this is what we call the relay, to interface between a circuit with one voltage level to another one, maybe to a different voltage level, or even in a different maybe amperage or amperage that is called current going to flow through that. Okay, so relays allow you to control high-powered electronics with low-powered signals from devices such as Arduino Raspberry Pi. So you can control different circuits, and one relay you can have. Let's say you have only one Arduino, you want to control several circuits. You can do that in terms of relays as well. This gives you the possibilities. It increases your possibilities of control and interaction. Okay, this is an example. You have your circuit here, and you're going to interface that with an AC circuit with a bulb, the usual bulb or light that you have at home, 230 volts. So you can use a relay module to help you achieve that. So let's read a bit quickly now. A device like an Arduino Raspberry Pi cannot switch high-powered circuits like lamps, motors. Use lots of relays, motors as well, drivers. These devices typically have 5-volt or 3-volt connection. And the other way, okay, on the big circuit, you have 230 volts usually, okay? And I guess from the countries that people are present today, we are using 230 volts, but there are some countries where you're using 110 volts and so on, but basically you would understand what I mean by higher voltages, like different voltages as compared to the circuit we are working with. Another use of relays is switching existing circuitry, which is what we call the retrofitting. We have an existing circuit. So if we want to implement IoT, we won't be changing a different circuit and do the wiring again. So at one place, you just add the relay. Okay, it's going to trigger, it's going to be like a switch, which is going to be controlled by the command from the Arduino circuit. Okay, such as a sprinkler system, you don't need to replace all the wires and so on. So use the existing infrastructure, the existing installation, and the relay is going to help you with your whatever Raspberry Pi or Arduino, which is going to do the control for you. So connect the existing power to the solenoid valve. So different types of relays. We won't get into the basics or the fundamentals of relays, the operating, but you should know that there's a device which can help you achieve much more, go beyond your control, the usual control capabilities that you have on a simple Arduino or Raspberry Pi. Okay, again, danger. Oh my God, this man is speaking only on danger. Let's have a look at what he has on this slide. So when working with high power levels, use extreme caution. Why? Because you have only one life to live. We don't want you to risk, okay, taking any risk when you're working with, or at times when you're working on a project, you get motivated, okay, inspired, it's working, yes, I see the lights is turning on, and you start working very quickly and so on, and you eat, or you go beyond, okay, you skip steps, safety steps and so on. So you need, that's why you need to stress much more on the caution part. Never work with wiring that is live. Okay, let's say you have introduced a relay. Oh, our presenter said that we need to introduce relay. I can make 1,000, 1 million lights go on. That's good. But then when you are working in such a circuit, remember it's live. We're working at a higher voltage. Always work with disconnected, or well, let's say you need to change a connection. If you're using a small, maybe Raspberry Pi, you can just change, okay, the circuit, change the wire, interchange the wires quickly without even turning the circuit off, isn't it? But when we are working at higher voltage, we need to adopt a new strategy. Not a strategy, but a protocol should be in place whenever we are going to interchange wires, disconnect wires, and so on. Take it maybe seriously, switch off the device, power, and so on. If you need to take longer, okay, if needed, turn the circuit breaker off, not only the switch. Okay, if you're working on the circuit but you're not too comfortable with, switch off the circuit breaker fully. And maybe if you're working on another floor, whatever, and the system is, the electrical installation is on the bottom one, the control, I mean, you need to lock it as well. So that someone say, okay, he's just entering, oh, there's no light, oh, the circuit breaker trip, let me just push it up, and then bow. You were trying to work your way in with your Raspberry Pi and preparing for Diwali, whatever, and this is bad for you. So at times you need to lock it or put a notice there, work in progress, don't switch on. Okay, for us in power system, we intervene on high voltage line and we put a what we call a lock. Okay, lock and key and so on, we put everything and we have the notice and so on there, because it's so serious. We have seen people lose their life like silly mistakes and so on. Okay, it's going to be about losing of their life. So just be careful and be serious, or consider all these safety precautions when you're working. Next now, when you're working with relays, you're going to solder it maybe to a board, whatever. This is going to be on top where you have all your components and so on. But at times when you're touching, okay, you're holding the panel or the board in your hand, your bottom finger or your thumb, whatever, is touching the bottom part of the relay on the board. So this part as well can conduct. Maybe you're not touching the upper cord, maybe where it is connected, you see the wires getting in, but what you have underneath as well, it's connected. That's why you have the tracks and so on. So both, they are soldered points on the bottom of the relay modules that are in direct contact with the high power. So be careful whenever it is power is on, do not touch the panel or whatever you are working. Switch it off first and wait. We are going to see why do we need to wait. Okay, then you can intervene. Make it safe way for you to work. You may have safely connected the power, but there are still connections that are not protected. With this in mind, do not work on metallic surfaces that may short circuit what you are working on. Even so, your hand, it may short circuit component, it may short circuit the tracks and so on. So be careful whenever you are working with that. Again, in the same breath, in the same philosophy, when you have electronic circuit, when you just switch on or you switch off, there's no power. So can you touch it? Just put it your hand and start touching the component. No. Okay, even maybe if you open up your television, you just switch off, there's no power. You even remove this, the plug from the socket, no power at all. It is off. If you just put your hand inside, you can have like an electric shock. Why? Because we have capacitors in there. What are capacitors? They are like, they can be, let's take that for us. This can be like batteries. They're going to store charge. So what are charge? When charge is flowing, exactly. Thank you, Hashim. Okay, we have capacitors in there. So this is going to store charge. So it's fully charged. When you switch off power, they are going to discharge. They're going to give out this. So charge is going to flow. So what is a flow of charge particles? It's current. So even though it is switched off, you can still have an electric shock. So you will need to wait for the capacitors to discharge, but they have the circuitry, have a form of discharging circuit for the capacitor. So just wait a few seconds and then you can intervene. Don't be like excited to just maybe touch here and there. Just be careful when you're working with higher voltage. So the capacitor discharge time is dependent on the resistance, which is connected in series usually, and the capacitance. The bigger the capacitance, the more it can store charge. So you will need to give it time to discharge. Okay, so be very careful about all these things. Next is, so we have seen about current. What are the different current? Or I think we talk about current a bit. And the circuit breaker is here. We talk about LCD first, one of the devices to protect us human beings. The circuit breaker, which we said we need to shut it, put it down, put it in the off position whenever we are working on our devices connected to higher voltages. So we need to put it off. These are here to protect an equipment. What is the use of the circuit breaker? Whenever you have a fault, a short circuit, whatever, okay? And LCD is here to protect human beings. It's here to protect us, while the circuit breaker is here to protect your equipment. Again, when you have a short circuit, it's going to be higher current, and it is going to create, it's going to damage your equipment. It can cause an explosion, it can cause fire, whatever. So LCD is here to protect humans. When I say humans, animals as well, while the circuit breaker is here to protect your equipment. Okay, whenever there's a fault, a higher current is going to flow, higher than normal, higher than design current is going to flow. Now this is current part, LCD and circuit breaker. Now we can have changes in voltage level as well. We can we can have voltage dips or peaks in voltage. How? When we have switching on the, maybe there's someone which is switching maybe a bigger load. Okay, big motor nearby, one of your neighbors switching on a big motor, if you have a lift and so on, and air conditioning starting up, it can create a small disturbance in the voltage. So it may go up or down, dips or peaks. So these peak and so on, if it is recurrent, okay, it can damage your circuit board as well. So how this is what we have, the basic one, the smaller one, or you can have even switching surge from the utility when they're switching off or on, or lightning, bijli. Okay, lightning is going to come, it can damage, can create a higher voltage on the network. You can see the different magnitude from there, but even 1, 2, 3 can be damaging to electronic installation. So how do you prepare, how do you cater for these things? So you can install what you call surge protection device. Okay, surge protection device, it is connected next to your breaker when your main cable is coming from your meter and so on. This is where you install it. So it's going to protect the whole of the installation. So you have different brands and so on. I won't be doing a bit of marketing here. So, but there, choose a good one because it's about protection of your equipment. Let's say your equipment is rated 230 volts. Basically, it can go up to 300 volts. It should be able to sustain 300 volts, but beyond that, okay, it's going to burn your equipment. This is why when you have switching, you have lighting and so on, you need to disconnect your plug, remove the plug from their socket most of the time, because you don't know where the lighting is strike. It can be striking the ground, it can go up from ground, and it can enter your house through cables and so on. It's going to damage your equipment. So be very careful. Install such an equipment if you have sensitive equipment, delicate equipment, and so on, because when we are speaking about IoT, these are electronic devices most likely, okay? And you have the antenna, the communication port, and so on. These are very sensitive equipment. So you're investing in these equipment and so on, so protect your equipment using a surge protection device. Okay, next one, still with safety. This is our friend. I don't know, maybe we'll need to have a name for him, maybe Irfan. I don't think Irfan will be happy with this one. Anyway, installing devices near to water outlets. This is a very clean installation, is it? Trunking, well laid. It's not just after the tile, well done, well installed, isn't it? Safe, I think maybe when you're taking your shower, you can even use your hair dryer and so on. So it's very clean network, good way of thinking, isn't it? Okay, so what are what do we need to share? What are the precautions that we need to take when we are installing maybe our equipment, maybe IoT device near to water outlets where we can have splashes of water? Let's have a look. what the standards tell us. Maybe bathroom zone, we are going to delimit bathroom in different zones, because there are some places in bathroom where you won't get splashes of water. In the bathroom itself, what we see is zone 1. Here it's going to be like you are going to have lots of splashes, okay? And those who are going to sing and dance and so on in the bathroom, they are going to have much more splashes. This is what we call the zone 1. Next is after, adjacent to this zone 1, we have zone 2, where you can have like some maybe not so frequent, but 1 times or 2 splashes of water. Then you have the outside zone, which we call the maybe zone 3 if you want to call it. So these are defined as a standard. And what do we need to do? Okay, we are going to use different types of devices. We can have, it's not that, okay, we are not going to install just like this guy did the socket in the bathroom. This is like wrong, completely wrong. Okay, just like Mozan's suicide. He's not going to suicide, he's an installation guy. Someone else is going to die, by the way. So basically, you can have a fan, you can have a light, you can have whatever, but you have what we call an IP, ingress protection, that so these devices, they need to have this ingress protection appropriate for the different zone. Here we have taken the example of the bathroom. It can be maybe if you're installing it in a cold room, okay, in different places, you will need to say, okay, what are the environment that these devices, or when we say devices, it can be your IoT device, can be your sensors, your actuators, and so on. We are going to define these in a short while, but all of these should be selected based on the IP. Okay, so if it is in water, you can have light. Maybe you're having a swimming pool, you can put the light there, but the IP should be proper. What is IP? Maybe you can have an IoT which is going to monitor the level of water in your swimming pool, maybe heat it up. You just, when you're coming home 30 minutes before, you just put it on your mobile phone to heat up your swimming pool and so on. So definitely you can have IoT devices over there, but still, what are the equipment? You're not going to use the board that you put next to the door for your final year project. Definitely not, because it's going to be immersed in water over there. So you need to be very careful. Anyway, you have different types of IP, but because the ingress protection, and this is what we have next. So define maybe for zone 0 is going to be, zone 0 is inside the basin itself. When you're going to have your bath, it's IP X7. What is X7? We are going to come to that. And zone 1 is going to be IPX4, in zone 2 IPX4 as well. So the outside zone is going to be general requirements that we use generally outside. Okay, so let's understand what is IP now. How do we read the IP? What you have on your right is one, I think it's an IP66 external probe high accuracy temperature sensor. So it is a sensor which we are going to use for our maybe industrial IoT or IoT in general. Okay, so it is IP66. So what is IP66? If we see the first digit 6 is a degree of protection for solid mechanical protection. Okay, let's say you are installing maybe a fluorescent tube in a corridor leading to a football match. Okay, the corridor leading to the stadium to a football match. Okay, let's say Liverpool, the fans are quite like, you don't know, because anyway, I won't mention anything because I can have a repercussion later on. Anyway, maybe what happened when the team is losing maybe 5-0? What happened to these spectators, these person leaving the stadium now? They may be a bit furious. They're going to maybe try to damage these lighting fixtures. Okay, I'm just taking it general. Forget about Liverpool, guys. Okay, and so they can damage the lighting fixtures. So what do we need to do? We need to have a lighting. We can't install one which we have in our home, in our living room, in this corridor over there. It's going to be completely different. There we need to have maybe some form of protection, maybe the mechanical protection, degree of protection, so it should be high. So no protection is no thing. It is like when it's a fluorescent tube, you can see it. Okay, or then maybe slightly as we go from 0 to 6, where it is maybe number 5 is dust protection, fully protected from dust, and 6 is dust tight. Not even one dust can get inside. So it's fully protected. This is number 6. So it is the highest value in terms of mechanical protection for things to get inside. Okay. Next is protection of water. Okay. This is what we call waterproof or things like that. So 0 is no protection. You can't put it in the swimming pool. As you go down, there are some splashers which are like accepted, 2, 3, 4. Maybe you're installing a light, maybe into your walls outside. So it's going to have rain and so on. So you can choose an IP. The second one, maybe 6 would be okay. Protection against water just from any angle. Okay. 4 should be okay for rain season and so on. But if you want it immersed in water, let's say for a swimming pool, you will need to go for maybe IP7 or IP8. IP8 is protection against high pressure water, submersion for an infinite time. It's going to remain there maybe at the bottom of your pool for forever. Okay, then you will need to go for maybe IP8. Okay, the last one is going to be 8. Mechanical one is going to be the amount of dust which is going to have. So the one that we have on our picture is 66. So it's dust tight. Okay, maybe dust proof. You can put it dust proof. And 6 here is protection against temporary flooding. So you can have 1 or 2 flooding and so on. So if you want to try, let's see if you have your iPhone with you, you can look for what is your protection that you have for your iPhone. I think iPhone 6, 7, and so on, you can put that in water. Okay. And but afterwards you will need to dry it. You can take pictures underneath water. Okay, but then you know how iPhone is. You have the speakers and so on at the bottom. You will need to dry it afterwards. You will need to switch off your computer, switch off your mobile phone, and maybe use a hair dryer to dry these mic and inlet and so on to remove water from. But it is, you can take pictures, you can record videos underwater as well with your iPhone. I don't know for Android, but for iPhone I can tell you. So check your IP of maybe your watch. Okay, waterproof watch. How far can you go? How deep can you go? For how much time? These are going to define the IP protection. So whenever you're going to choose your sensor, your actuator, whatever, you need to be careful about what is the IP you're using. Okay, next part now. Small break for me to just. Okay, let's get going. So Internet of Things now. We say Internet of Things. What are these things? Anyone could say it. Everything, isn't it? We have a minister here who say everything. Okay, the IoT devices are connected physical things. What are these things? Devices, sensors, transducers, actuators. But what are these sensors, actuators, and so on? Let's have a look. These are what are going to be enablers to help us. So you have different, these are what are our sensors? As human beings, what are our sensors? We have 5 sensors. We can see, hear, and so on. Basically, when we are transferring this skill or sense, let's call that a sense, to the IoT device, they are going to take decision, they are going to take measurement, they are going to have to send back all the information. So they will need to have a form of sensor. We can't remove our eyes and put it there and see what is the water level. No, we can't do that. You will need to have a sensor to do that. So we have sensors that we can see to detect motion, velocity, displacement, for temperature, moisture, humidity, acoustic, sound, vibration, everything. Chemical, gas. We even have one, I think, for odor as well. I don't know how it works. For taste as well. Okay. Force, strain, load, leaks, level, electromagnetic, lots and lots. I think we have over thousands of sensors around. Okay, but what are sensors? What are actuators? And so what is the role of the sensor? What can it do? What can't it do? Okay, so a sensor is a device that detects, measures, or indicates any specific physical quantity, such as it can be light, heat, motion, moisture, pressure, etc., by converting them into other form, which is mostly electrical pressure. So it's going to sense. This is what it is going to sense. It can sense maybe a change maybe for physical parameters and so on. Maybe if you want to, how does a mercury in bulb work? Okay, mercury in bulb thermometer, you just put it maybe under your arms. What's going to happen? It's going to sense the heat. What's happening? It is expanding. So we are using the physical property when a solution or whatever, a metal, is going to heat up, is going to expand. So this expansion is going to give us a sensor. This is what we call, for all of these, it's about a mechanical property, not a mechanical, a physical property, which we are investigating, okay, which is helping us see or feel or whatever these things which are changing in the environment. Okay, it's just going to sense, the sensor is just going to sense, and then it's going to convert that into another form. It can be electric, most of the time it is electrical pulses. Okay, it's going to convert that into electrical, but it can be, it convert that, maybe if you have a pneumatic system, it's going to convert that into motion. Then what do we need to have? A transducer gets in. A transducer is any device which converts one form of energy into another. Let's say you have a pneumatic system. This sensor is going to convert this pneumatic change into a motion, and then the transducer is going to convert this motion into electrical pulse, usually. But now this is the fundamentals of the basic definition of sensor and transducer. But nowadays, with miniaturization, things are getting smaller, and we can include both of these on the same board. At times we use sensor, which include transducer, or both, vice versa. So ultimately, but fundamentally, a sensor is different from a transducer. But basically nowadays we have all in one package. We call that maybe a sensor, transducer, whatever, but we use that at the starting point. Now, what is an actuator? The sensor is at the initiating point. We are getting information. They are sending information. This is going to go through your network and so on afterward. But what is the actuator? The actuator is going to do the action. Maybe you say, okay, switch on, the level in the swimming pool is going down. Open the tap. So how do we open the tap? We don't have Aladdin and so on here, okay, with the magic, whatever. Okay, so what do we need to do? We need to have a device. When we send the command, they are going to switch on maybe the tap, which is going to fill in the reservoir or the swimming pool, whatever. So this is the role of the actuator, device that actuates or moves something. An actuator uses energy to provide. So we need energy. What do we say with energy? So this is where we interact with the electrical system. Okay, we work with the electrical engineering, electrical system, because for it to work, maybe for it to move, it will need to have power and maybe a motor to switch on or off. So it needs to be connected to a source of high power, maybe 230 volts, whatever. However, the actuator, okay, it can be working on lower voltages, maybe a small IoT device which you interconnect there, and this is going to do necessary afterwards. Okay, so this is what we call a sensor. We have the transducer and then the actuator. The main difference between sensor and actuator is that the sensor is used to monitor the changes in the environment, while an actuator is used to control the environment. It's going to bring changes to this environment. Good. Next, there are a wide range of IoT sensors used to detect and measure various physical phenomena, such as heat, pressure, as well as 5 human sensors: sight, hearing, touch, taste, and smell. So we have everything nowadays. Okay, up to you to choose, and then maybe you can invent as well. So where does it pin? Where is it found in the flow chart? Okay, you have the analog sensors, the signal. At times the sensor is a signal is too small, you need to amplify it. Okay, then you have, if it is analog, you need to convert that into digital nowadays, because basically everything is going to digital. You connect that to a microcontroller, and then you have the IoT network, which is going to come after. This is your baby, okay, the IoT network. Okay, so you know exactly where these fits into the bigger picture now. Okay, in terms of sensors, we said we can have proximity sensor, pressure sensor, image sensor, gas level, gyroscope, and then temperature sensor. But let's focus on new one. We won't go through all of these. Okay, let's focus on proximity only. Okay, proximity. See the proximity sensor. Proximity sensors are used to detect nearby objects. Something is getting near and so on, or you are reversing in your car, you have a proximity sensor. These sensors are largely used in the autonomous vehicle sectors, warehoused by autonomous robots, whatever. Okay, some of these type of proximity sensors include, so what are the phenomenon they are overseeing? What is a physical idea behind these, what we call sensors? Okay, so we have one which uses inductive sensors, we have one which uses capacitive sensors, and one which uses photoelectric sensors. Three types of physical parameters which changes, and we can use these as sensors. Let's focus on the first one, which is electromagnetic radiation. So it uses electromagnetic radiation to sense nearby objects. What does that mean now? It is a good property, but when we are choosing, not choosing, when we have an environment where we have lots already inherent in the environment, we have lots of electromagnetic radiation. What's going to happen? Isn't it going to affect your sensor? So point which I want to make here is while choosing the correct sensor, you need to be aware about your environment. What are the different things which are going to affect the correct functioning of your sensor? So instead of using maybe an electromagnetic radiation type, what you call an inductive sensor, you can go for a capacitive sensor, or else you can go for a photoelectric sensor. So you need to be aware about when you're designing, you need to be aware of, okay, this is an environment I want to implement my sensor in. I want to use this sensor. Then you choose, okay, which type is going to best fit my environment. Okay, this one we have just taken the example of proximity sensor, but for all of these proximity, all of these sensors that we have around, let me just show you this one, another example as well. It's a connectivity IO sensor. So when you're going to go through the selection, analog input, okay, you're going to see analog input 0 to 10 volt DC or 420 milliampere. So this is what you have in terms of the input to this. No, this is not the sensor. This is a box where you can you add all the sensors going to take the signal here and send it to somewhere else. You have the digital input, you have the UART, and you have the sensor power source. Most important for us in this slide is industrial temperature. Where can we use that? Minus 40 degrees C up to 85 degrees C. If you're going to operate at night in an environment, maybe in a special kitchen, in a furnace, in an industrial environment, going beyond 85 degrees C, so you can't choose such a device. Okay, it's not a sensor. It's just going to pick up all the information and then send it to somewhere else. If it is going to operate below minus 40 degrees, you will need to go select another device. Okay, so be careful. Let's see for a cold chain monitoring as well. The sensors are designed to handle the harshest environment or refrigeration environment, including the operating of oil and so on. Basically, you can read through that. But what I want to tell you here is that, let's say it is operating in a very cold environment, humidity. So you will need to choose not only sensors, but all the devices. Maybe you need to be careful about the IP you are choosing, the sensors, the actuators, if you need to take action. Okay, at times, if it is working in a cold environment, it will be freeze. The system, the mechanical system may freeze. So be careful. Maybe if you have, it's oil, the mechanical system. If it is too cold, the oil is going to become solid. So it's going to block the actuator to work. So you will need to look for another type, maybe pneumatic system and so on to work. So these are a few of, not a few, yes, maybe 10, 20 of different sensors, thermal sensors, transistive sensors, lots of sensors that you have. So selection of sensors is very important for your IoT project. Okay, you need to be very careful and you need to take that into consideration in terms of the environment and different things that we have just discussed. Next, in terms of sensors, we have active against passive sensors. So active sensors are parametric sensors, require an external power source to operate, such as a GPS or radar. Okay. Passive sensors are self-generated sensors, okay, they can operate on their own, generate their own electric signal, and do not require an external power source. These include thermal sensors, electric field sensing, and metal detecting. Okay, up to you if you want to have an active or passive. So you can choose. There are some which are available, some are not. So maybe if you have an active sensor, you will need to interrupt it. You will need to interface that with an external power source. Okay, so be careful. You may need to look for a source of power. At times, if you are installing it on top of a pole, where do you get this source of power over there? Okay, if it is in a house, you can have the source of power. If it is somewhere around in nature and so on, how are you going to? Maybe if you are following up a bird, if you have put a sensor maybe on a bird and you want to track where this bird is going, so how are you? You can't put maybe a few batteries, okay, on top of the bird. Okay, it's not going to work. So you will need to choose what we call passive sensors for these maybe projects and so on. There's an interesting paper, okay, comparison of active and passive device sensors for IoT application. I've included the link here. If you want to read it, you can download this paper. Next is contact and non-contact sensors. Basically, what you are used to that nowadays. Everywhere you go to the supermarket and so on, they're just going to gun you down. okay, takes your temperature. So this is what you call the non-contact. This is what you have in the pictures, non-contact sensors. But basically what we have in the past, when I was maybe smaller and so on, younger, we used to go to the doctor. They're going to take the mercury in bulb thermometer, put it under your armpit, wait for a few minutes, and then they're going to read the temperature. This one was contact sensor. They had to touch you and to take the measurement. This one uses another technology, okay, maybe magnetic sensors, optical sensors, whatever. It's non-contact. So you will need to know when you're choosing those sensors, you will need to be aware about all these differences that we have. Next now, do not overload. Okay, we have this maybe I'll take it on me. At times we have this capability. Okay, I need to have another power source here and so on. I just put it next to the on the same maybe extension cord. This is what we call an overload. What's going to happen? It is concentrated power. It's going to heat up. Heat is going to create some burns, and this can catch fire, and ultimately it can result in maybe fire in your house or whatever industry, whatever you're working. So avoid all these. Use a proper maybe extension bar, okay, with the appropriate cables and so on. And this one, as you see in this video, in this picture, it is temporary, should be temporary. This type of message should be temporary, maybe this extension socket and so on. But if you leave it like this for a long time, you will see it is dangling in there. It's not properly fixed. Okay, this is used for temporary use only. So while it is dangling, it is moving in the socket and so on, it's going to create flash and so on, and it can cause like fires and so on ultimately. So it's like a poor connection. So avoid all these when you have a lot of sensors or IoT devices. In terms of connection, be careful. At times, this may be acceptable for our small project, but when we are going at industrial level, we are going for professional level, this should be avoided. We should be using appropriate, this one as well. It's going to work, definitely. The system is going to work, but it is not safe, not recommended. This one, acceptable. I would prefer maybe using the common domino one, tight, and then you can insulate it with insulating tape later on for a proper connection. Okay, now when we need to retrofit, that's good. We say that, okay, we can't throw our television, we can't throw our refrigerator out. We are going to retrofit. We are going to add intelligence to these existing devices. With time, when we need to change, we are going to get one which we have inbuilt intelligence in it. But we can't retrofit everything. If you have an old wiring, we can't just retrofit the old wiring with the IoT devices. So poor wiring, what we had 30 years back, has gone. The design, whatever was designed for different purpose, we can't use such an installation nowadays. Poor wiring is the biggest electrical risk facing any home or installation. Faulty, old or damaged wiring leads to fires, power outages, and so on. So be very careful. Avoid interfacing with old installation. Next is color coding. You need to be aware about color coding. Okay, for what we have for Mauritius, we use the in some installation, okay, in some apparatus, you can have the red and black. Red is for live, black is for neutral. And then it's always true for the ground, which is yellowish and greenish, yellow-green, you have it. But for installation, the blue is neutral, the brown is for the live. So be careful when you're, why is it so important? Well, let's say you are installing, you're interconnecting the relay. Okay, on which will you connect it to the neutral or to the live? Be very careful about it. You should always connect it to the live, not the neutral. Okay, so be very careful. The live, the neutral should be going through. The live is where you have the relay inserted, and this is going to control when you're going to switch on or off. Cable management system now. Okay, so we'll just a few maybe slides from the end of this presentation. So building automation and energy conservation system, such as room occupancy. So basically what you have in this slide, you have, let's say we are moving towards green building nowadays. Everyone wants to have lots of sensors. Yes, we need to adopt IoT and so on. Very good philosophy, very good maybe decision. But then you need to interconnect all these devices if you have maybe lights and so on. So for basically one technology, what you're using, not technology, but an approach is power over Ethernet. Okay, they use a lot of these data cables. So you need to know how to route all these cables ultimately Wireless is good at some point, but you will need to wire these devices. So lots of devices in a building. In a house, it is manageable, but in a building, it's going to be huge. So we'll need to cater for cable trays and so on. This may be informed, maybe a part of industrial IoT as well. Okay, now when we connect, we wire where we have, definitely we do have our power cables nearby, and we are going to install maybe communication cables. We have what we call electromagnetic interference, which can happen now. Okay, so electrical energy of the power cables can have significant effect on the performance, integrity, and safety of the communication cable. Why performance? Because it can cause some interference, it can cause noise. Noise is going to affect the integrity. Maybe 1, 0 becomes 0, 1, whatever. Or can cause some malfunction, some maybe noise in the system, as we say. Or safety. Why safety? If you are putting your power cable very close to the communication cable, the power cable, remember, is going to heat up because it's carrying huge current, not huge, but design current. And when current is passing through a cable, it's going to heat up. This is normal, inherent. So your network cable is next to it. It's going to heat your network. The network cable has not been designed to sustain heat. The power cable has been designed to sustain, the insulation that you have on it has been designed to sustain the heat, but the communication cable has not been designed. So it can cause safety. It can burn or it can damage your communication cables. Cable design and placement are very important to ensure that EMI, electromagnetic interference, or dangerous levels of electrical energy are not induced into telecommunication cables. So you have what we call a process of induction. Okay, this is going to create a magnetic field, the current passing through the conductors. Okay, and if it is crossing, this magnetic field is crossing another maybe cable nearby, especially if it is running in parallel, this is going to create another voltage over there, and since a complete circuit, a current can flow as well. So it's going to induce a voltage in there, and this is what can cause, like, maybe affect the integrity and performance of the electric cables, what we call electromagnetic interference. So what do we do? What do we do when we have to lay power cables and communications cables near next to them? So you have different types in terms of IT cables. You have screen, unscreen, or screen. So this table, as per the standard EN 5174, is going to give you what is the minimum distance that you can. If you're having an aluminum divider in between, these are the values. So these are given in inch and millimeters. Steel divider or non-metallic dividers is what you have. So you can consult that to give you an idea about what are the distances that you need to keep. But there are some different types of what we call trunking nowadays, where these are already separated. You already have this, so this has been taken into consideration. But you need to be aware about that, because trunking can come from different parts of the world, and they may not go according to these specific standards. They have their own standards, so be very careful about that. Other problem areas when it comes to electromagnetic interference, okay, can be when it is, you have a generator nearby, maybe in the same building, and you have cables. Usually this is in some specific area, which we call a service area. Excuse me. You have generator, standby generator, maybe transformer and so on. This is where all your cables are going through. But you need to be very careful about, you need not put the communication cables next to these sources of electromagnetism. Okay, high voltage electrical panels, induction heaters, fluorescent lighting fixtures, electrical motors, medical equipment as well, factory machines, definitely. Okay, so be very careful, just to highlight these things. Last part for today. Okay, battery consideration for IoT. You say that, okay, we can't put a power source on the bird, but can we include a small battery? Okay, on the device that we are going to put on the bird, or maybe another device, maybe a wearable, whatever. Okay, so what are the considerations for battery when you're going to select? What are the considerations for battery? Okay, so number one, the battery type and electrochemistry. So we need to be aware what are the different types. We have alkaline battery, we have lithium ion, whatever. So it's like a topic in itself when we are going to talk about battery. Okay, and the temperature in the field, because the lifetime, the rate of discharge of the battery is affected by the temperature. Remember, if you're operating in an environment where it is very cold, it is very hot, we need to be aware this is going to affect the choice of battery as well. The rate of discharge, how are we going to discharge the cable, the battery? Is it like 1 or 2 times per day when it is going to be triggered, is going to discharge a bit to send the signal, or is it going to be continuous throughout the day? The voltage range, okay, what is the voltage range? It is using 5 volt, 10 volt, 12 volt, whatever. The leakage current of the various components of the device. Inside the device system, they have a small loss, let's call that a loss, where it is going to consume this device, this power from the battery. Okay, so what is it? You need to be aware about that for the design part. The battery shelf life, how long can we store it? Okay, as you know, battery have an expiry date. Okay, storage condition and duration before the battery is integrated into the device. Maybe you buy in bulk, maybe you're going to use that in 5 years, but after 2 years, the battery has expired. You need to take that into the shelf life, how much time is going to remain onto the shelf. The device's shelf life, storage condition, even though it is on shelf, maybe if it is a store, it's going to heat up, so you need to have ventilation and so on to keep it to the proper temperature. So these are different. We're not going to go deep into that. Okay, just an introduction. Just to trigger what you need to know when you're going to select battery. Okay, so let's read that quickly. The level of energy that is stored in a battery is represented by its nominal capacity. We call that an ampere hour. How much ampere? Ampere is a measurement of current in terms of hour, in terms of time. So if we say 10 ampere hour, so it can supply 10 ampere for 1 hour or 1 ampere for 10 hours, ampere hour. The capacity will determine the battery average runtime for a given application whatsoever. But what I'm going to help you with that. So you have an online battery sizing calculator. You can scan this code, whatever. Okay, but I'm going to leave the PowerPoint as well with you later on. We're going to look for a way to share it. Okay, so you can scan it. It's going to give you link access to a website where you're going to input the different maybe application, rate of discharge, and so on for your specific use. They're going to recommend to you what is the most appropriate battery to use. Okay, so you can use that as well. Okay, final words now. Let's summarize if you are still around. So you can see a few, wow, lots of you still around. Hopefully not sleeping. Okay, IoT electrical. So we talk fundamentally for today about safety. Lots of things which we shared on safety, number 1. Number 2 is relay, how you can use much more capacity. Okay, you add more load or devices to your board, to your Arduino, whatever. Okay, using relays. And then we have a look at protection in terms of RCD, circuit breaker, surge protection. Next, we look at ingress protection, what we call IP. Remember, in the bathroom and so on. Sensors, actuators, we introduce sensors, actuators. Number 4, have a look at electromagnetic interference, because it can affect the way, it can affect the integrity of the data, the way your system is going to operate. It can malfunction as well. So be careful about this selection, about where the cables are going to go, where you're installing your device and so on. And then you have number 5, we just quickly go through what we call battery system, and you have a link to help you do your sizing as well. This said, thank you. This was the end of the presentation, and let me just try this one out. So it's going to be thank you for some, it's going to be merci for others, Saha for a few of you, Asante for others, and Shukran for those coming maybe from the Middle East, and then Yashek for some of our friends from elsewhere. So that was it from me. And now I'm going to have a look at the questions. I don't know if the MC is going to go through the question, or how are we going to answer the questions that we have. So that was it from me. Thank you. And let's go for the questions now.
Anyone who has any question, you can please write it in the chat box.
Let me just check the chat box in the meantime. Okay, yeah, for AC voltage, depends on frequency as well, definitely. 60 Hertz is more dangerous than 50 Hertz. I agree with you. Is there negative and positive in AC? Okay, or is it just DC? So DC is just, it can be fluctuating DC, okay? but basically the DC, the common DC is like flat basically. But for AC, what is AC? Let me just clarify this with you. Let me just add. Okay, if we are having a, oops. Okay, this is, we call that DC. This is 0. This is time. This is going to be voltage. Here we take it the usual DC that we have. It's constant DC. Okay, but how about this one? This is voltage. This is time. This is 0. So what is this one? AC or DC? This one's a tricky one. Okay, Shahrukh is saying DC. Oh my God. Okay. So basically the second one, this one is DC. How do we compare? How do we differentiate between AC and DC? AC, we need to have change in polarity. Here, it is a fluctuating DC. We call that a fluctuating DC. We have only positive, or we can have only negative value. So it could have been, maybe this is a 0 mark. It could be like this. This is a negative. It's going to remain negative. But for it to be described as an AC, it should be having change sign like this. Like this one is positive, this one is negative. So change in polarity, then we see it is AC. Okay. So this is one of the questions that we have in terms of the chat. Let me go back to the chat now. Dun, 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 dun. Okay. Travel, believe, very good. So yes, you get away with this by electromagnetic by communications cable. Yes. Okay, not related, but another case of electromagnetic radiation, case around the globe where background radiation sometimes flips in bits in circuit. Maybe I see a comment from Hashim. Okay, cosmic rays can flip bits in computer memory as well, definitely. Okay, but we can't control everything. Okay, and link for the lecture, please. I think I'm going to share it with the organizer. They're going to look for ways. I think if you registered, you have the email address and you can share the PowerPoint with you. Okay, similar to the IoT, do you have similar regulations for IoT? This is from Mr. Hulas. I don't know. Maybe do you have regulations for it? I'm not too well versed in IoT, and maybe those who can help you for this question. So the question is, do we have similar regulations for IoT? Okay, next question. Why do we use drivers instead of transformers in low circuits and LED? So drivers, we have much more control. Okay, with drivers, we can program drivers. Okay, for transformer, and transformer take much more space. Okay, and but in drivers, we can do much more. It's much more adaptable for our use. Drivers is much more, have much more flexibility for drivers. We're more and more exposed to electric storm, a recommendation to protect IoT setup exposed to outdoors. So, okay, for electric storm, it can be in terms of lightning or whatsoever. So we need to have what we call a Faraday cage. We can protect our devices, what we have, the sensors, whatever, in some form of what we call a Faraday cage. Okay, and let's just like IP. Yeah, we had a small box where it is protected against water, dust, and so on. So we can have like a small box or things container to hold our circuitry and so on. But it's going to be like a Faraday cage. So whatever is going to happen, let's take an example. Let's say you have, let me just draw, clear all these things. Let's draw. Okay, let's say you have this is supposed to be a car. Hopefully you can see that. Okay, you are driving in there. Okay, as you can see, Shahrukh is around. Okay, so Shahrukh is driving the car, and you have a lightning strike onto this car. So basically, since this guy Shahrukh is not going to have any electrical, maybe discharge, whatever, because the car is metallic, and it is. Shahrukh is inside the car. So this car, the frame of the car, is going to act as a Faraday cage. Okay, so whatever is inside is safe because all the charge, okay, we have learned that in physics, I think all the charge are going to remain on this surface only. Okay, and this guy here is going to remain safe, but if he decides to go out, then things can start to change badly for him. Even though you have maybe an electric pole here and a wire has broken, has fallen to the core, remain in the core, my friend. Okay, don't go out, remain in the core, you're going to be the safest place. So still now, if you apply the same philosophy, you can have what you call a Faraday cage. You have your equipment in a box with metal casing and so on, and all your things are there, your sensors, actuators, antenna. I don't know antenna if you need to have it outside also, but then this is going to protect if it is maybe lightning strike this one, the outer part only is going to remain to have this extra charge whatsoever, but inside everything is going to remain. You can have like a metallic cage, okay, metallic cage, and you put someone inside. He's not touching the cage, okay, and then you electrify this cage. This person, this outside casing is going to have the voltage, but this person inside is going to be safe. Okay, it's a philosophy where we use. I don't know if you have seen, yeah, most likely if you're buying your RAM and so on, or what do you buy RAM and so on, you get it in a plastic, a small plastic, which is a bit, you have some bit of mirrors and so on with it. It's slightly different types of plastic. So this is going to be like a Faraday cage as well. It's protecting the electronic components in there. A few more questions coming in. How do we protect our devices against back EMF? So back EMF is most likely going to come from motors and so on. So basically, if you're using your IoT should be like, if you're using in relay, you won't be having this problem with back EMF usually from my perspective. Okay, so using the relay can decrease maybe this danger that you can have, this maybe mishap is what you don't want to happen in terms of having back EMF in the back EMF is going to flow in the main circuit, but it's not going to affect your circuit, your small circuitry, which is for the IoT device. So what are the risks of IoT? I won't be able to answer this one because it's like lots of dimension, depending if you're speaking about electrical, I can answer you maybe the risk. We have talked about the risk of electrocution and so on. And this is it's not only for IoT. When we talk about electrical, we have this risk, which is general. But if you're speaking about the IoT risk associated with IoT, I think you have lots different types of risk, maybe of someone else controlling your devices, maybe your information getting to different places. Maybe yesterday we had some type of malfunction, of a blackout for Facebook and so on. So what happens when you're used to these technologies and you have some form of blackout? How would you operate? Maybe if your house is regulated, you just need to come in and the door is going to open by itself, and you have such a form of blackout and you don't have any key itself to open the door, what can happen? So these are maybe a few risks of IoT, but maybe other maybe panelists ultimately are going to answer this one for you. If we are from Julius, if we are working with projects that requires radio frequency transmission, is there any limit to the frequency to be used in IoT? Okay, so these frequencies are usually regulated, and you have some institutions which are going to regulate, okay, which frequency you can use. I think IoT, they are going to use a specific range, a specific band, which we call what we call for scientific medical use and so on. I don't remember the correct term, but you have a specific band band that you use for IoT project. Okay, you will need to stick to this radio frequency. If you are using another radio frequency for transmission, you will need to get the approval, okay, because it is like a spectrum of radio frequency is shared, and you need maybe to buy this frequency. You need to have access to this frequency. But for that, IoT, I think, is going to use this band, which is for medical use, for educational use, and so on. Okay, there is a specific brand where, let's say, for radio frequency for cars, toy cars, and so on, radio control. So they are using the same band. So IoT should be using the same band, if I'm not mistaken. From Pascal, do we have expertise on this island to be compliant? Does CB commission such setup? No, CB is more, I don't know whether we have it. Basically, I think should be, we have lots of well conversant people in this IoT domain. But for the CB, we stop at the meter part. Okay, CB is where the meter is, we are going to stop there. The internal installation is to the applicant, to the customer. But there are I know if you have worked on a few projects with very good youngsters, okay, he managed who works well with IoT, and they are very well versed in this, what we call the IoT business and technology. We do have some expertise on the island, from what I know from those people whom I've met. From Ashbin, can we build LoRaWAN based IoT network in Mauritius? This is what the band, ISM band, industrial, scientific, and medical band. I don't know for Ashwin, LoRaWAN ban. I don't know what this means. Maybe someone else is going to help me on that. Maybe the panelists, the organizers. Drivers protect circuit from voltage fluctuation. Yes. Yes, sure. You can have it, definitely. I think this is a comment. And most houses are cable with optical fiber. Do we need to disconnect in case there is lightning or storm to protect our? No, the fiber cables we don't have. When is lightning important is when we have a connection through conductors. Okay, optical fiber uses what we call total internal reflection. It is using what we call sometimes of mirrors in there. Okay, so it won't conduct lightning current whatsoever. So it uses what we call optical properties. Light travels in there, so we are safe when we are using optical fiber in case of a storm and so on. You will need to ask for ICT. Okay, that show it is licensed. Thank you Nadim for answering this one. Hello sir, can we have a quick view on how smart grid work? Smart gig is like, I think it's like a presentation in itself. Maybe you can organize that. Maybe Zuleika can take note of that. We can have another session, maybe outside this IoT festival, to talk about smart grid because it's subject in itself. Okay, thank you for showing interest in that. And made the link of today's presentation. Okay, I think we have covered the questions. Let's see the question and answers. Do I answer? Okay, I think this has been answered. Last one, what are factors to consider when deciding to size an electrical wire to use? Okay, so Zakaria, this is an interesting question. It is a design question for electrical engineers. I have it's a process that you need to go through quickly. You need to calculate what is the load that you are going to, what is you're constructing an installation to supply a specific load. What is it in terms of watt and so on. And then you select in a list of available cables or wires, what is the one which is closest. Then you need to look at the protection. What is the protection device you're going to use, because this is going to affect the cable you're going to choose as well. So it is fuse, it can be circuit breaker and so on. This is going to dictate. There may be a change in the size of the wire you're using. And then ultimately you need, if it is longer distances, you will need to check for the voltage drop as well. Okay, and if with this correct value that you have chosen for the cable or the wire, it is going to have voltage drop beyond the acceptable limit, you will need to go to the next size, maybe up size, and then you check for voltage drop again until you have which is within acceptable range. Then you need to look for the protection spot as well. Okay, but it is like a 1.5 page of calculation, or you have software to that, but the philosophy is around here. We just need to calculate the load, what we call the design current, and then we need to check for the protection. Is it fuse, circuit breaker, whatever you are using? Do the voltage drop calculation, and then check for the loop. In case we have a fault, remember we discussed about RCD and so on. We just need to calculate the fault, loop impedance, and so on. Okay, so I think I've answered basically all the answers which are electrical in nature, and a few questions maybe on IoT has been answered by the participants themselves. So that was it from me. So maybe the MC is going to take over from there. Thank you for this opportunity to share a bit of knowledge with you.
Thank you so much, Dr. Ismael. Coming from an electrical engineering background, I thought I knew almost everything from what you were going to share, but I was wrong.
Okay, at least you have learned a few things, that's good. I think we lost Zuleika.
Yes, sorry, it was network. Yes, I hope it was fruitful for every single one of you. And we can conclude the session today.
Okay. Thank you, everyone. Take care. Stay safe at your place. Bye-bye.
Bye.